In this presentation, I'll be talking about microplastics and why they're increasingly treated as an emerging form of particulate matter. I'll cover what they are, how they move through the air like particulate matter, what we know about exposure and health impacts, why measurement of them is hard, and then then the most practical mitigation ideas. So, what are microplastics and why are they considered a new form of particulate matter? Microplastics are usually defined as plastic particles that are smaller than 5 millimeters across, and nanoplastics are even smaller. They can be below 1 micrometer. When these particles become airborne, especially as fibers or tiny fragments, they behave like other aerosols. They can stay suspended, they can travel, and they can deposit with rain or snow. This is why people call them an emerging form of particulate matter. It's not in itself a new size category like PM 2.5, but it's a new composition within the particles, within particle particulate pollution that routine PM monitoring doesn't capture well. So, where do airborne microplastics come from? There are two big stories for airborne microplastics: textiles and indoor materials, clothing, carpets, and other synthetics shed microfibers, and then they can be suspended by activities like walking, vacuuming, and reviews consistently flag indoor air as a major exposure setting as well. Another method is transportation. Tire and road wear creates polymer-rich particles, and then a fraction of those particles is small enough to overlap with PM 2.5 and PM 10. Studies and reviews now quantify meaningful contributions in some settings. Now, transport and deposition, it's not just oceans. A major shift recently realizing that air is not just a local pathway. Measurements and models show microplastics can be carried and deposited far from obvious sources. This means that remote regions can receive inputs through atmospheric transport and deposition. And at the same time, exposure can be very personal. Cars, indoor spaces, these can concentrate airborne particles, and newer studies measure microplastics in homes and vehicle cabins to estimate inhalation and inhalation relevant levels. Now, exposure and health. So, for health, when considering microplastics, the key is to be accurate and balanced. We can really have exposure through inhalation and ingestion, but there's a growing body of work reporting microplastics detected in human tissues and fluids, suggesting that particles can be taken up by the body. Major health agencies like WHO have emphasized that risk assessment is still limited by inconsistent methods and gaps in dose-response evidence. This is especially for nanoplastics. So, exposure is widespread, and there are plausible mechanisms that exist like irritation, inflammation, chemical additives that hitchhike on particles. However, because of the uncertainty that comes with tracking small particles that overlap with other particles like PM 2.5 and PM 10, they're still building evidence needed to have an accurate quantitative health risk estimates. So measuring microplastics as particulate matter is hard because a lot of air quality particulate matter instruments are optimized for mass, micrograms per cubic meter. However, microplastic studies typically report particle counts per cubic meter. These don't transfer very clearly because particle size and density vary a lot. There's also contamination. It's easy to add fibers from clothing, or lab materials if strict blanks and controls are not used in testing. And then finally, to confirm something is actually plastic, it requires some sort of spectroscopy, like micro FTIR, or some sort of chemical method like pyrolysis. And this makes standardization difficult across several labs. So, what we can actually do about microplastics. So, forms of upstream source control, like reducing textile shedding, improving filters, and reducing tire wear through design and policy. There's also capturing downstream. Road dust controls and stormwater runoff management can reduce the redistribution of microplastics. There's also exposure reduction indoors, ventilation, HEPA filtration, low shed materials, and policy-wise, the big need is standardized monitoring methods and more attention to non-exhaust PM and microplastic fractions.